Today class we're going to go over some postulates, and of course they are also known as axioms. Now we have three main ones. Our first one is going to be the alternate exterior angle. The second one is alternate interior angle. And the third is congruent angles. So if you have two lines, and these are both parallel, so we have line 1, line 2, and we're going to write over here, line 1 is parallel to line 2. And say you cut it by a transversal line. So when two parallel lines are cut by a transversal, according to the congruent angles postulate, it forms two congruent angles. So we're going to go ahead and number our angles. 1, 2, 3, 4, 5, 6, 7, 8. So you have two congruent corresponding angles. Then the two lines cut by the transversal are parallel. On top of this, if two parallel lines are cut by a transversal, that also gives us alternate interior angles, which are 3 and 6 or 5 and 4. Recall, 2 and 6 are also congruent angles. If you are given a pair of alternate interior angles that are congruent, then two lines cut by the transversal are parallel. So this also proves for the converse of if two parallel lines are cut by a transversal, then it forms the congruent angles or whatever corresponding angles. The converse of that is also true. If you have two congruent angles on parallel lines, or on a line on the three lines, then that means these two lines are parallel. And so that's another way to prove not only the actual axiom, but also the converse of the original axiom. So if you're given a pair of alternate exterior angles that are congruent, then two lines cut by the transversal are parallel. Alternate exterior angles are the angles on the outside. So we have angle 1 and we have angle 8, and those two angles are equivalent. Same goes with angle 2 and angle 7, and same with those. Those two angles are going to be equivalent. On top of this, we also have a supplementary rule to where any two angles that are on the same straight line, so for example 4 and 6 will equal 180 degrees. And so this is the supplementary rule. So these are consecutive interior angles. And so I'm going to go ahead and write that over here, consecutive interior angles. And so that means angle 4 plus angle 6 equals 180 degrees. Now our next section is going to be over how the axioms and all the postulates correlate with each other. So you might be confused on how when you have one axiom, you form your theorems, correct? Well, to start with a certain axiom, it doesn't have to be the same axiom every single time. You can start with different axioms because in the end of the day, they're all going to be true. All of these postulates and axioms apply to the two parallel lines cut by a transversal. So regardless of which axiom you start with, it's always going to give you the same proof. So you'll be able to prove your theorem regardless on which axiom you start with. Axioms are here to help us develop, and they're meant to be advanced. So for example, our axioms are going to develop as we go and as we go into higher math. For example, the Euclidean geometry or the SMSG axiom that starts off with a point, then you form a line, and our axioms just continue to build on top of each other, sort of like layers, or It starts off with a small foundation. So we start off with a small foundation of how angles are correlated, or how the supplementary angles, and then the straight lines, and then the 180 degrees. So they're just all sort of correlated, and that's how axioms and the interior angles and congruent angles all are correlated with each other. Thank you for class.